Well, welcome to this online event of the Materials and Embodied Carbon Leaders Alliance, MECLA. Today we shine the MECLA spotlight on designing out carbon. Design is such a crucial and powerful stage in any construction project to determine the aesthetic and functionality of the built form. As we will hear shortly, it also presents a huge opportunity to design out carbon. My name is Hudson Worsley from Precinct, and I have the tremendous pleasure of being the chair of MECLA and hosting today's event. I'm joining you today from Gadigal land in the Eora Nation, and I would like to acknowledge that we are all on Indigenous land. I pay my respect to elders past and present and welcome any Aboriginal and Torres Strait Islander people joining us today. Quickly to the mechanics of this session. We're recording the event, and the event is being viewed by over 540 registered attendees. I think that's a record for a MECLA Spotlight. So thank you for joining us. Welcome to you all. Please use the chat function for comments and the Q&A function for questions. I'll do my best to field the questions in the panel discussion, and speakers and attendees will no doubt respond to comments and questions as we go. Always a very active part of our spotlights. As always, I'd also like to remind MECLA members and attendees today of our governance requirements. MECLA does not tolerate any anti-competitive behaviour. We operate in a pre-competition environment, and if you're aware of any conflicts of interest, please speak up so we can adjust accordingly. Today, we will be joined by 5 fantastic speakers who will cover a range of perspectives on how their profession is designing out carbon. Firstly, Paul Stoller, Director at Atelier 10, will give us a quick introduction to embodied carbon and the balance between embodied and operational carbon, the big picture design opportunities, the power of design to tackle embodied carbon, and the many future lives of buildings, including reuse and disassembly. Philomena Bashara, Sustainability Manager at Built, will talk us through the Guide to Building Disassembly Plans, a resource that Built has now made freely available on its website, and we'll have access to that after Philomena's talk. Paul Reedy, a partner at Fitzpatrick and Partners, will then dive into 3 project examples shown at the recent Perth Design Week, and we'll explore the design steps and iterations, touching on data, living buildings, design for disassembly, and how we are starting to think about design differently. Looking forward to hearing about that thinking. Tom Petty, co-founder at Carbon Trace, architect and residential builder and tech entrepreneur. Tom will give us an overview of Carbon Trace, a tech startup which has converted 1 million Natters energy certificates into Australia's first residential benchmark, which can compare single homes against the state average, demonstrating how simple design decisions can reduce project emissions. Finally, we'll hear from Dr. Dominique Hess, Chair of Greenfleet and an active member of the Australian Institute of Architects. She'll present the Embodied Carbon Roadmap, Toolkit and Curriculum for Architects, which is now online for the Institute's members. That is a lot of content, so let's get on with it. Paul Stoller, can I please ask you to take it away?
Thanks so much, Hudson, and good day, everybody. It's a real honor to be here. I'm going to share my screen and we will get going. All right, is that coming through?
Yes, it is. Nice.
Great, thanks, Hudson. So, again, g'day. My name is Paul Stoller. I'm a director of Atelier 10. I'm going to set the stage to talk about what are the kinds of emissions, carbon emissions we think about and how to consider those as a designer when you're looking at projects in the built environment. And just to note, that's what we at Atelier 10 do every day. We imagine kind of what is the more sustainable world that our projects can contribute to, brainstorm a whole range of ways to deliver sustainability outcomes. One's in the brief, one's beyond the brief, and figure out the most effective way to get there. So this is a really exciting time. The climate is changing, and we as an industry are moving rapidly to catch up. I wouldn't say we're not changing, but we need to keep changing our practices and our thinking, and that's at the center of my talk. We have spent a good solid decade of neighbors data-driven Green Star rating assured thinking about how to reduce our operational emissions, the emissions that come when we buy power from our grid, which has a lot of emissions associated with mostly coal-fired power plants. Thought a lot about how to reduce those emissions. We're doing a very good job of that. But we are now in an era where we need to think about all of the steps to reduce emissions in our buildings, from the embodied emissions and the materials and the construction, right on down through to pretty wonky things like fugitive emissions from refrigerants, green power, which is getting less wonky, thankfully, and so on. So I'll be talking about operational and embodied emissions as a designer, which are the two biggest chunks. So just a reminder that when we talk about embodied emissions, we're talking about the greenhouse gases that are emitted when materials are extracted from the ground, processed, turned into products, moved to your site, put into your buildings, and gotten ready to run. They also deal with the end of life of your materials, what happens after they come out of your building. That will be more the subject of Philomena's talk, and better ways to find new life for our products. Also a reminder that operational emissions are associated with the power we buy. It's the stuff that comes out of smokestacks at coal-fired power plants or gas-fired power plants, much in discussion these days. And we'll note that globally, greenhouse gas emissions in most power grids are going down because of the renewables being added to our grid. You can see here the emissions intensity of the UK power grid, which sort of fell off a cliff in a good way between 2013 and 2019, to the point that it's very radically changed the way we think about designing buildings overseas. Here in Australia, we're not quite that far along our journey, but we are moving quickly to add renewables to the grid. So what does this mean for our buildings? Conventionally, we thought, oh, operational emissions really sort of dominate, especially when our buildings weren't very efficient. But with a good, new, energy efficient building, we can see that even now, with our current grid emissions, we've got, embodied carbon is dominant for at least the next 20 years in a typical building. We really need to think about embodied carbon as much as we think about operational carbon. Now, for designing super efficient buildings, the embodied carbon is dominant. So as a person, as a company committed to absolute zero carbon, we spend a lot of time now driving down embodied carbon in our projects. The operational carbon is of secondary importance, and it's also less time sensitive because we need to get rid of emissions now, and the embodied emissions happen now. Interestingly enough, as our grid decarbonizes, and what we're seeing elsewhere in the world and is happening here, and as we add renewable power to our buildings, either directly or buy it when the emissions are low and store it, we also see that the embodied emissions, not only they dominate forever. So really, we need to get rid of embodied emissions is the name of the day. Let's just talk about, in the transition, what do we do about reducing our operational emissions beyond good practice? Essentially, we need to rethink how we think about carbon, think about total system benefit. This funny graph on the left is called the duck curve. It's the emissions intensity of the grid. You can see as we come into a typical day in the middle of the night, there's a background power load. As emissions come online in the morning, as the sun shines and the wind blows, you can see the emissions intensity drops. And you can also see over the years, it's dropping more and more as more emissions come online. In the evening, when everyone goes home, the sun's gone down, emissions spike as we all get our cookers running and our heat pumps running for heating or cooling. You can see on the right side, you can see the emissions intensity reflected in a 24-hour cycle as the renewables come in and out. We need to shift our loads to that most efficient, emissions efficient time of the day. Here's real data from just a few months ago comparing typical emissions intensity between April and May. Just as a reminder, as we move into winter and the sun is less intense, you can see our grid emissions going up. You can also see there is the duck curve here in Australia. So what we want to do is store energy in our buildings when emissions are low, typically during the day, and discharge it when emissions are higher. So really practical things you can do without buying a single new piece of kit. So no embodied emissions intensity penalties with this. Yeah, you can pre-cool your building. So when it's morning, emissions are going down, you can run your building on the cold side, and then let the temperature drift up during the day. No, that's not a design thing, but that is what everyone can do right now with their buildings. That's done at buildings that are well run all around the place. UTS Business School does that. Sydney Opera House does that. With a little bit of kit, adding in some thermal storage tanks, you can run your buildings, say on a weekend, store up thermal energy, hot water, cold water, whatever you need, and discharge it the next day. You can buy yourself time of day or even kind of multi-day power shifting. And that just raises a practical point of what kind of design consideration does this need? You can already do it to some degree just by running hot or cold. But if you leave space in buildings for thermal storage, essentially tanks to store chilled water or hot water, you can do pretty active load shifting. And thermal energy storage is as good as electrical energy storage. It's a practical way, very low tech, to store energy so you can generate your cooling or heating when the grid emissions are low and discharge them when the grid emissions are high. This is practically a great way to move towards what we call absolute zero carbon. More on that in a moment. And the next step beyond that is not just thermal energy storage, it's battery storage. So just like we store thermal energy, we store electrical energy in electrical batteries, charge those up when grid emissions are low, discharge them in your building when grid emissions are high. Now, some would argue we should be doing this at grid scale. That is where a lot of it's happening, but there are practical benefits to doing it at building scale. We move the load around, we reduce the need for transmission lines. There are big system benefits. Also, there's real cost benefits. If you participate, if you actively manage your power to buy it when it's cheap, when the emissions intensity is low during the day, you reduce your building outgoings, your operating cost. If you participate in a virtual power plant, there's ways to get rewarded. So having space for power energy storage on site is step number one in how do we reduce operational emissions, store energy when the intensity is low. And I'll note this is a critical thinking shift that's happened overseas and should be starting to happen here. California has fundamentally changed the way that carbon performance is measured. It's called total system benefit there. Atelier 10, we wrote a paper on this several years ago, the future of carbon neutral design, exploring how as designers we consider the importance of time of day carbon use and energy storage. So you're welcome to find that and download it. It's on our website. Just the critical thing is here, we have to be thinking about operational carbon and embodied carbon back and forth. They interact, they need space, they have consequences. It is not just a one and out process, not just operational, not just embodied. And I mentioned before this term, absolute zero carbon. We at Atelier 10 and many we work with in industry, acknowledging the importance of offsetting, which gets us to net zero carbon, which we all are committed to. We also need to think about absolute zero carbon, actions we can take right now to reduce actual emissions right away without having to compensate elsewhere. This is the most effective way to get to a climate active outcome. Again, we've written a paper on it. You're welcome to download that. Now let's shift gears and talk about getting rid of materials. The best way to reduce our embodied carbon, which goes into the atmosphere right now, is to get rid of material. And here's just a graph showing where the bulk of the material is. The bulk of it's in the structure. So structural engineers, this is your chance to be a hero. Architects, this is your chance to be a co-hero by not putting undue structural demands on your projects. Again, it's depends on the kind of building, but the vast majority is in structure, superstructure, and facades and MEP. Again, more than half typically in superstructure and structure. Finishes matter, FF&E matters, and fit out matters, especially because it tends to churn at a high rate, unfortunately, but the vast preponderance is in the building core. So practical things we can do as designers include, like the project on the left, take an underloved old building and give it love and make it awesome and new. We've done really great examples of that in a very deep way here in Sydney with Key Quarter Tower and the Greenland Residential Tower. Those were old structures given new life to keep their cores and floors active. So, substantial, deep, adaptive reuse retrofits, really great examples. Other things you can do where you are doing a new building, get rid of basement space, get rid of structure, get rid of materials, think structural efficiency. A huge amount of embodied emissions go away when you rationalize your structure. Specifically basements, lots and lots of material, lots of embodied carbon. Basement space can be low value. Often there's parking, which is high value in Sydney still and elsewhere in Australia, but there's a huge amount of emissions tied up in those substructures, especially in the works to hold them up. So just get rid of them. That's really critical. Build lower. You can see the taller we build, the more we've got to do with wind load, pushes up the core loads, et cetera, et cetera. Not to say we don't do tall buildings, but you can see there's a point of diminishing returns around 30 stories. It also happens to work out well with lifting. Form factor matters a little bit. We wouldn't normally push this one hard because if you get buildings too, let's say, cubic in proportions, you end up with bad daylight in the middle, but it does matter a bit. Column grids, these matter a lot. If we reduce column grids even a little bit, we can knock 15, 20% out of the total structural volume. That is real dollars saved. It freaks out the leasing agents, but they'll come around eventually. It's a long game. Cantilevers, a little bit for drama, sure, but fundamentally, they are enormously material intensive. There's an example here in Sydney of a building under construction right now where a design excellence proposal to get rid of columns to make a more dynamic street presence has led to the equivalent of 20 stories of floor, concrete, and steel for one transfer level. 20 stories of embodied carbon to get rid of 3 columns. You know, I appreciate that streetscape may be a little more dynamic, but I don't think that's worth it. We've got good data now on relatively carbon efficient structures. Essentially, reinforced concrete frames are the most effective way to go to balance spans with relatively low embodied carbon structures. Timber is also good, of course. Spans are a bit lower. Timber is also lighter, which reduces foundation loads. That's one of the real carbon benefits of timber, is it makes for lightweight foundations. Something new we are seeing in the UK is not just building with less, but actually taking old buildings, disassembling them, and putting those materials to use in new buildings. So existing office buildings that are coming down, steel frame, quite different than Australia typically. Those old buildings are being bought, disassembled by the builders, and the steel is putting back to use in new buildings. This is a market has been generated for this, and it is active. Massive embodied carbon reduction. And this is, again, steel reuse. Take the old steel, cut it, test it, cut it, put it into a new building. MEP, we've made systems very complicated in the service of ultimate efficiency. We are now making them less complicated to get rid of kit. That extra little bit of marginal performance is just not worth it in terms of embodied carbon, massive uptick. So lots and lots and lots of these things that together get us to substantial embodied carbon reductions. It's a long, hard slog. There is no silver bullet, let us be clear, but we need to tackle them all. I'll note, you know, we're getting better data. MECLA is central to that, getting better data. We're all developing better methods. We all need to keep sharing those methods. It's critical to do that. You're welcome to scan these, look at some of the tools we've developed to tackle embodied carbon, which includes games, because God, this can be so tedious sometimes. You know, carbon accounting is, oh, for the obsessive compulsives out there, cool. I know you love it. I love it too, but make it fun wherever you can, so you can also raise awareness. Design processes have to change and are changing, so that we can better balance operational emissions, which are perhaps a bit less important than they used to be, compared to embodied carbon, which is absolutely important right now. And a reminder, we need to do this in parallel, in sync in all of our projects. And with that, thank you very much. Back to you, Hudson.
Thank you very much, Paul. I have to say, I didn't find that tedious at all. But I'm glad you've added in the human dimension of keeping it fun, because yes, it is a long, hard slog. Thank you very much. And yeah, that link, maybe you could drop the also links to the reports you referenced into the chat.
I'll do that.
I'm sure there'll be many eager participants today who'd love to have a look at those. Thanks, Paul. We'll come back to you in the panel session. Next, I'd like to hand over to Philomena Bashara from Built. But you guys have come up with an amazing report, fantastic addition to the common knowledge in the sector. Tell us about it.
Thank you, Hudson, and thank you everyone for having me. Just one second while I adjust my slides. Okay, can you all see everything okay?
Fantastic.
Okay, beautiful. So yeah, just like reintroducing myself, I'm Philomena Bashar. I'm a sustainability manager at Built. And today I'm going to tell you a little bit more about our newly released white paper on how to write a building disassembly plan that Built co-wrote with circularity consultant Corio. So just like a very quick snippet about who's Built. We're a construction management company. We are the third largest company that does that in Australia, and we have offices also in the UK and New Zealand. We have been around for over 25 years. And let's talk about the problem. What really pushed us to write a paper around design for disassembly? So we're all here, so we probably all know what's the impact of buildings on total global carbon emissions. It's huge. But the other problem is that the Australia building industry is also responsible for a big chunk of all waste generated in Australia. So in order to solve these problems, we need to think about the construction industry in a more circular way. And design for disassembly presents itself as one of the solutions available out there. So a quick reminder for people who never heard about design for disassembly. What is it? It's really a design technique that enables material components, products to be dismantled at the end of the building's life cycle, so they can be reused, resale, donated, or recycled. As I said, it's just like one of the tools in toolkit in order for the building industry to become more circular. The white paper that we wrote focuses on how to write a building disassembly plan. And you're probably wondering, what is a building disassembly plan? So if you think of an IKEA manual, it really tells you step by step how you need to assemble all the components of your piece of furniture so that it comes together. And a building disassembly plan is obviously for a building, and it's a little bit of a reverse of that. So it's a manual that tells you, how do you take this building apart from the first component until the last one? And we found that this was a crucial document if we're thinking about designing for disassembly, because you must have all the right information available for when the building is going to be coming apart, so that you can disassemble all the components in a non-destructive way, so that you can reuse them elsewhere. We thought it was really crucial also because, potentially a building that is designed for disassembly is going to be taken apart 10, 20, 30 years after project completion. And therefore, it's very important that there is a document that is the only source of truth and that compiles all the right information so that its component can be taken apart and be reused elsewhere, while the building has probably changed of ownership multiple times during that period of time. So why we think that design for disassembly is relevant? Well, first and foremost, because, big reminder, we actually have a target in Australia to be 100% circular by 2030. And currently Australia is probably in the single digits. And also for whoever's been paying attention to this, there's been a flurry of policies that have been coming up in the last couple of weeks that mention circularity and specifically design for disassembly quite a lot, especially if we're looking at the recommendations to the government by the CMAG or the environmentally sustainable procurement policy, which is going to be affecting a lot of government projects. So these policies are not just pieces of paper, but they're really strong signals from the government telling us where do they want the construction and building industry to go. And it's becoming harder and harder not to listen to those signals. The other reason why we think that design for disassembly is really relevant is because, as I mentioned before, buildings have a huge impact on the environment, and design for disassembly presents itself as one of the solutions in order to first lower the carbon emissions associated with new construction buildings by using existing materials and honoring the embodied carbon that is already embedded in these materials. And what that allows is not only to lower the carbon emissions associated with new construction, but also to minimize the negative impact on nature by reducing the need for virgin materials. We keep saying that the most sustainable building out there is the building that already exists. Well, that's the same for a brick, a window, a piece of furniture. If you're using materials that already exist, that's your most sustainable option right there. We also find that potentially there could be some synergies between design for disassembly and improvement in productivity on site, because design for disassembly naturally tends to stir design teams towards modular components, which could enhance productivity as well. So the white paper that we wrote expands on all these concepts, but at the same time, we've provided some Word templates for you ready to use. The first one is a template around a suggested structure of a disassembly plan that we put together based on an existing project. again, like you can literally download the template and start typing in the details of your project and try to write your own building disassembly plan. And the other template that we made available are ready to use questionnaires that need to be sent to subcontractors. So you are able to collect consistent information from the subbies. At the end of the day, they are the expert in the room when it comes to their scope of work. So they have to give us some information around how to take the elements that are relevant to their scope of work apart. So it's important that they compile the questionnaire, which is going to become the meat and potatoes of your disassembly plan. And the reason why we share these resources is because at the end of the day, we realize that as you might have heard before, that circularity is not a solo sport, is a team sport. And by us working on one building and doing a disassembly plan, 1 or 2 buildings is really not gonna generate the scale of change that we need to see to make it to 100% circular. So it's very important for the industry to feel empowered to design for disassembly and to and that's why we're sharing these tools, because we hope that other builders, developers, and architects are going to decide to take this initiative on. One second. Okay, so the paper is also going to include a sample section. So again, this is based on a real example of writing a disassembly plan. It's going to include a little paragraph around, what building component we're talking about, where is it located, exactly like an IKEA manual, as I explained before. And then there's going to be a narrative about how these components can be taken apart in a non-destructive manner. And then narrative can be translated in many different ways. It can be made through the use of BIM models or marked up shop drawings, photographs, depending on the owner's directives and the ways the subcontractor feels more comfortable in generating that information for you. The section is also going to include a paragraph about storage and notes for recovery, so that 10, 20, 30 years from now, whenever you're taking those elements of the building apart, you also know how you need to store them properly so that you can retain as much value out of it as possible. The paper is also going to include frequently asked questions. How do I start designing for disassembly? There's plenty of resources out there, so we're going to point you in the right direction. Talking about what is the value of design for disassembly, what are the enabling factors, how to make it happen on a project. And also my favorite question, the one that I get asked the most, which is, does it cost more? And also we included some case studies from other projects that have implemented design for disassembly, and we share some inventory platforms that are available here in Australia to facilitate data collection in case you want to go a step further on your project. And finally, we have included some insights from writing a design for disassembly plan on projects. We are really keen to hear from the industry, get some feedback, and improve the way we are doing design for disassembly in Australia. And that was everything from me. I invite you all to please scan the QR code or go on Build's website and go check out our latest paper. Thank you.
Philomena, thank you very much. I think the key word there was non-destructive disassembly. I think we've all seen the bulldozers and the grabbers and the ripping apart of built form. So yeah, keyword. And also the fact that you touched on cost. One of the questions in the Q&A was about that. So maybe if you could respond to that in the Q&A, but great that there's a case study that goes to that, because I think anyone with a commercial interest in a building will be asking that question.
That'll be the first question, Hansen. Thank you.
I think so. Please hang around. We'll come to you in the panel discussion, but thank you for your presentation and for that terrific guide.
Thank you.
All right, next up we have Paul Reedy, partner at Fitzpatrick and Partners. Paul, over to you.
Thank you very much. Okay, get myself sorted. Hopefully you can see that. Why can't I get to... There we go. All right. So I'm Paul Reedy from Fitzpatrick and Partners Architects in Sydney. I'm going to rattle through the first three pieces of this, hopefully relatively quickly, in order to get to the case studies. Case studies I'm going to show are a built project, which is an adaptive reuse, a project in design that's an adaptive reuse, and a living building challenge project that we're working on at the moment as well. I'd like to start with an acknowledgement of country. Our studio is on Gadigal land, as is one of the projects I'm going to show. The other two projects are on Camaragal land and Wadjuk land in Perth. I'd like to pay my respects to elders past and present and emerging. For Fitzpatrick and Partners, design and carbon strategies kind of started as a how do we start? How do we move forward with I suppose, a series of strategies? So on the left-hand side, we've got some really big picture strategies around not building on greenfield sites, planting more than we remove, honoring existing already spent carbon, and remembering within all of this that we design for human joy and delight. We don't design to remove carbon. That's a part of the process of getting there. And then some tactical steps on that: no fossil fuels in our project, minimizing energy that we need, so building efficiently, and maximizing green power gets us to effectively a net zero operational carbon position. Topic of today's talk, which is minimizing embodied carbon, offsetting what we can't remove, and Paul mentioned offsets earlier. Agree, bit of a bad topic, but anyway, our aim is for regenerative design, so being carbon positive, leaving more than we take away. Everybody's probably seen the diagram or a version of it on the left-hand side, which is about the quantum of carbon that's in buildings relative to everything else. Today, we're going to talk about the bottom slice, which is embodied carbon. The diagram on the right really talks to the history of where carbon in the atmosphere has gone and where we need to take it. At Fitzpatrick and Partners, we're taking a pretty pragmatic, optimistic approach to that, which is to say it's a straight line between 2 points. We need to plan for it and just get on with it. As part of doing that, understanding where and what is really important, as I'm sure a lot of people have probably seen this slide or a version of it before. Embodied carbon and operational carbon put together make whole of life carbon. And in the discussion around carbon, whole life carbon is really what we should be talking to Paul's earlier point about focusing too much on one or the other is a bad thing. But today we're going to focus in on embodied carbon. Embodied carbon is made up of the in-use stage and the upfront stage. Another way of looking at that is the pie chart. So they're effectively 50-50, not quite. In terms of where the carbon is, the first half is the project, the construction project, the architecture project, etc. This carbon is released into the atmosphere before the project is occupied. That's upfront carbon. The other half is the embodied carbon in the occupied life of the project. That's largely the refurbishment of the elements over time, which is to do with how long the building lasts. Our focus is on this front bit in terms of where the architecture project is, to look then at where within that the scale of the different components is, and this is for a generic office building, and the numbers slide around a fair bit between different sectors, but fundamentally superstructure is the biggest, substructures second, and generally speaking, facade, MEP, and internal finishes as a hierarchy. Another way of looking at that hierarchy is in terms of our ability to deal with it. So if the white outline at the top is the embodied carbon baseline emissions, the impact of the embodied carbon as to what we can reduce with what we know today is in blue, and you'll see that the first four are all structure. Now, the relationship of these four might slide around, and I'll show an example in a bit where it does. The fifth one is envelope, and again, we can have some pretty significant impacts there. To Paul's point, internal finishes definitely matter, but the impact of each of them in terms of an overall percentage to start with isn't as great. So we started by looking at structure. An approach that Leddy have put forward, which I think this is a Leddy diagram, it's a really great diagram. First and foremost, build less. So if you don't build at all, that's no carbon. If you build less or build more efficiently, that's good. Build light. Conceptually, that's about grids and structure and some of the points that Paul made earlier. Build wise, which is circular principles. As Philomena talked about, build in low carbon or biogenic materials, build for the future, which is definitely what Philomena talked about, designing for disassembly and circularity, and build collaborative. We can do this together. We can't really do this at all on our own. From Fitzpatrick and Partners' point of view, we added to that, I suppose, some first steps, which is accept responsibility. Architecture equals carbon. There is carbon in architecture. That's a fact. We've got to start with that knowledge and move forward from there. We got to learn as we go. I think the industry as a whole has a deficit in terms of knowledge. Get measuring, you can't manage what you don't measure. Understand the supply chain. Why is one person's concrete different to another person's concrete in terms of its number? Remember that there are rabbit holes and you will disappear down them. Just come back up for air from time to time. And then sharing and advocating is really what today is about. From Fitzpatrick's point of view, we developed an embodied carbon tool. You can get it at embodiedcarbons.com. It allowed us to analyze against 3 different data sets to understand that the 3 different generic data sets all gave us different numbers and that the numbers weren't consistent. And we learned a lot by understanding that kind of process. But that's a tool that's available publicly with two freely available ones being Epic and ICE as well. And we've used that to be able to chart all of our projects against trying to get to some form of benchmark. So the benchmark that we're looking at here in pink is the LEDI 2030 design target for office. And we've reduced that for just the structural component of that, and then be able to measure with the blue triangles, which are the ICE database, which is the relevant data set for LEDI, where our projects sit relative to that. Some of them are below already, which is fantastic. Some of them are above, which is something for us to learn. And generally that's around smaller projects or really, really tall projects. More of that later. So first one is 73 Miller. We completed this project about 2.5 years ago in North Sydney on Camaragal country. The building was a 15,000 square meter B-grade office from the 80s, which we were looking at either pulling down or significantly refurbing. Keeping the existing structure and services saved an awful lot of carbon, and honoring the past materials of the building and the fact that it was built over a series of different ages gave us a bit of a unique proposition in terms of the way that the architecture came together. That's what it looked like when we came to it. Very 1980s building, lots of angles, lots of terraces. It was pretty tired, pretty anonymous from the street. And we changed that to look like this. So we added 4,000 square meters of building. This building now contains TTW's offices, LCI's offices, Oricon's offices. Engineers love this building. There's other people in there as well, but it's come together as a really good project. I think some of the real outcomes for us, reusing all of the existing structure and services saved significant carbon. We ended up with 19,000 square meters of A-grade office building for only 4,000 square meters of new structural carbon, which reused 7.1 million kilos of carbon. The structural carbon cost only 21 kilograms of CO2 a meter squared, which is by any metrics awesome. And that's because we only spent 4,000 to get 19. The building also has 100% green power, 5-star Green Star and 6-star neighbors. It's got a solar farm on the roof and series of other really good upgrades as well. So that's a built one. The next one is a building that we're out to tender on at the moment. So carbon case study for reusing spent carbon at 86 Bay Street. Really exciting project. It's awesome, isn't it? I'm sure everybody loves it. Ours is the building in the middle before, an ugly duckling, and after. So what we intend to build at 86 Bay Street fits in between two heritage projects, maintains all of that existing building's structure, or the vast majority of it, and puts a new building on top of it and around it. So in essence, what we've done is we've maintained the bottom 4 floors, which are concrete. We've brought a new light well through the back of it. We've added 3 stories on top in timber. So the focus has been first and foremost on embodied carbon. Secondly, it's a fully electric building, so no fossil fuels. It's got a solar farm on the roof. It's got operable facades both to the laneway and to the courtyard, and a whole series of other really cool initiatives in terms of sustainability. But the big move here was keeping the existing building. Rather than demolishing it, we, by keeping it, kept the slightly lower floor to floors on the bottom 3 floors, which allowed us to sneak an extra floor in. So from a project finance point of view, this made a lot of sense, as well as from obviously sustainability perspective. So the first thing that we did was assess the new build on top in timber rather than in concrete. That saved us, retaining the existing building saved us 450,000 kilos of CO2. Adding the new floors in timber rather than in conventional concrete saved an additional 410, and we avoided spending 1.7 million kilos by demolishing it and building it again in concrete. So all in all, a really good story in terms of the embodied carbon numbers, using the app to assess against different data sets and really get an understanding of where the big bang for buck was. So I'm probably going to spend most of my time on this, which is a Living Building Challenge project in Perth, in Wadjuk country. Living Building Challenge, for those that don't know, is a really great tool, a really great philosophy about how to build. This building will produce 105% of its own power on site. It'll capture and reuse all of its own water, including black water treatment, super high performance building envelope, which really drives down energy, and more about that in a minute. Embodied energy minimization has been a real focus, and there's some real lessons to learn in that. Optimizing for transport use, it sits within a couple of 100 meters of a train station. Biodiversity is another great part of the LBC, and the 10% of this building's roof will be an urban farm. And then obviously the aim is to build an exemplar live-work building. So a whole series of different initiatives. I'm going to focus in on the carbon-related ones in the main. The first of which is to make the carbon apparent. So in this instance, what we did was look at the building as its materials. So in blue, sorry, I'll just move you guys out of the way. In blue, you'll see the concrete. In pink is rammed earth. In green is blockwork, and yellow is timber. So it's a single basement for 12 cars, end of trip facilities, a gym, and a lot of plant space. That's in concrete and rammed earth. Above that, it's mass timber and rammed earth and brickwork walls. And then the structural grid has been optimized for material efficiency. This is building light where we can. So everything above ground is in timber, fundamentally as a structure. We then looked at that ground floor slab. So this is talking about building wise. And we looked at 9 different options for that ground floor slab. We analyzed them in a 2-bay grid. And we looked at the carbon content of each of those using conventional concrete and steel to see where the carbon was. We then looked at, well, what happens if we use a geopolymer concrete and conventional steel? And option 8 in this instance went from 19,000 kilos in that 2-bay grid to 9.5. Option 3 is only 9.8, so 9,800 kilos in that 2-bay grid. So this is about relativity rather than about final numbers. We then looked at what happens if we use reused steel and geopolymer concrete, and we were able to push option 6 into the mix, which was steel beams and metal deck slab, which got down to 6,800. In the end, we didn't do that because we couldn't get the steelwork tested without shipping it all over the country. And that became something of a problem for us. So rather than do that, we opted for the conventional system, which is reinforced concrete flat slab with drop panels, that got us to 9,800. So already half what the previous number was, and relative to the top number, which is 73,000 square meters, which would have been a very beautiful brick vault. But we did that to try and save carbon, and then realized there was an awful lot of carbon in what we were trying to save. So we opted for option 3 in that instance. We then look at carbon in terms of building low carbon. So when we analyze the building, this fundamentally looks, feels, and is a timber building. But when you look at the carbon's all in the bottom of the building. So looking at it by structure, B2, which doesn't actually exist, it's just tanks and piers or piles, sorry. B1, which is our first floor, is our biggest component of carbon. Then the ground floor, of which in blue you can see the carbon that's in the concrete, level 1 and level 2. Or looked at across elements. The biggest elements are actually the piles and the footings, followed by slabs and walls. So that's an awful lot of carbon to get to this building, and that's to do with the fact that we built a basement on land that is pretty soft. Then we looked at building in low carbon. So rather than having that B1 slab at conventional concrete, we looked at what happens if we go to a Boral Envisia type product and we save 280,000 kilos. We looked at it, we're experimenting with BGC on a really high performance, low cement concrete, and saving about 450,000 kilos. And then we looked at a geopolymer concrete, which would have saved us even more, proving very difficult to get it in Perth. So we're still looking at building in low carbon, if you like, within the material that we're building in. This then is a very detailed slide. The top 3 diagrams are plans through the external wall fabric. The bottom 3 diagrams are roof sections. So on the right-hand side, you've got an NCC compliant wall and roof at 1.4 OR and 3.7 OR. On the left-hand side, you've got our ESD target, which was OR5 and OR7. And in the middle where we landed, which was OR4 and OR5. And this is really looking at the HVAC energy, which is consumption of HVAC in kilowatt hours, going lower, obviously, in the proposed and lower still in the ESD target. But the savings in that are converting that kilowatt hours into kilograms of CO2 for a consistent measure. 12,000 kilos of CO2 saved going from conventional to the proposed, and a further 3,000 to go on to the ESC target. We looked at the embodied carbon in that. So the embodied carbon in the walls was an additional 1,300 to get to the proposed, and an additional 1,900 on top of that to get to the ESD target in the walls, and in the roof an additional 9.5 and an additional 24, which is largely to do with the insulation buildup going from 50 to 100 to 200 millimeters in order to achieve the OR target. Another way of reading that is that sorry, I'm going to have to move you guys again. The saving to go from conventional to where we ended up was 11 months. So this number divided by that number got us 11 months. To go further to get to the ESD target would have taken us an additional 8 years. All of these numbers are very difficult in that this building, obviously, as I said at the start, is 105% of its own power on site. So this is a bit of an abstract conversation, but you can see the impact of trying to get to the right number. Then last couple of slides, just in terms of material innovation was a really big point on this project as well. So I've talked about cement replacement in the concrete. We're also reusing the excavated material from the site construction, crushing it and bringing it back on site for aggregate in the concrete. Also for the rammed earth, which will hopefully give us a really nice limestone color because it's limestone we're taking out. We're working with the Natural Brick Company on a brick product that they've got, which has got about 40% wood, recycled timber from pallets being used in that. We're using save board in replacement of plasterboard. We're using bamboo for floors, ceilings, and glazing frames. We're using Bettastone bench tops, which have got recycled glass of about 80% content and only 1% silica. We're using sheep's wool for acoustics, which is obviously renewable in and of itself. The bathroom tiles are 80% recycled textile and glass. And the carpets are, where we do have them, are cradle to cradle certified. Final couple of slides then. In terms of circularity, spent carbon first. So that's about materials, reusing materials as much as possible. Robust design. So understanding your supply chain. A bit of a plug for Product Aware from Architects Declare. If you don't know what it is, go and have a look at it. Material innovation, which is a real focus, and obviously working with biogenic carbon storing materials as much as possible. Future focus, which is designed for disassembly, and obviously human health, which is building in materials that are good for us, not bad for us. My last slide, and I always like to finish with this one, do the best you can until you know better, and then when you know better, do better, from Angelou. Thank you. How'd I go on timing, Hudson?
Pretty good, considering you were threatening 16 or 17 minutes. Very good, and look, really fantastic. I think case studies are always great to make it real, and the way you've stepped through each building element and all of the considerations at each stage before you even look at material selection, and then you get into the materials and some innovative materials there. So really looking forward to bringing you back into the conversation, but thank you for that. I was scribbling notes furiously. That was fascinating. So thank you, Paul. Next, we're going to turn to Tom Petty, builder, architect, tech entrepreneur. Makes you sound like you should be flying in a corporate jet, Tom. I know that's not the kind of tech entrepreneur that you are, but I'm very keen to hear about Carbon Trace. So take it away.
Thank you very much, Hudson, and thanks to MECLA for being such an important part of an understanding of embodied carbon and bringing together so many different components of the industry. I'd also like to reiterate deep respect for First Nations people, particularly in any conversation that's involving the urgent need to decarbonise our current society. Carbon Trace came together, myself and Ben Crine. My background's architecture, been 15 years building residential homes, fell down the embodied carbon hole 5 years ago and met Ben last year. He's a civil engineer with a fascination for optimization of structure and cost. We came together and started to look at the need to tackle residential embodied carbon specifically. And so today it's this kind of scale shift, I suppose, my bit of the presentation. The residential sector is one of scale. We're supposed to be building 200,000 new homes a year. And the question is, how do you measure it? How do you start, design, or understand and unpack this landscape at this sort of scale where the literacy level is relatively low, the costs attached to it are negligible, and the industry seems to be in a state of paralysis. We saw the opportunity to use a NatHERS certificate as a way to start to measure and unpack the cold shell of a building. It's a sort of a low cost and low friction way to start to put some numbers around the embodied carbon attached to construction at scale. NatHERS being consistent and scalable in itself. We were very interested in trying to create a benchmark, which again, NatHERS lends itself to, in that it's been around for a long time and has a lot of data. So we've built a,
Hey, Tom.
Yes,
Just Dominique here. In the chat, somebody's saying the PowerPoint's not visible. Can I just check? Hudson, IT people in the background, can you just check what's going on? That is now. Okay, they're all good now. Sorry to interrupt.
I could see it, Tom.
Okay, I'll jump it up.
Just to confuse you. Yep.
How we go? We good?
You can see it now. Yep, all good.
Excellent.
Thanks, Tom. Thanks, Tom.
Thanks. So we take a PDF energy certificate, we drop it into our carbon trace algorithm and use AI and all sorts of tricks, and we can spit out an embodied carbon analysis in a couple of seconds. Essentially, we're using a cold shell approach, that is picking up the big ticket items, which the other speakers have spoken about: foundations, external walls, roof and glazing, all of which are captured in NatHERS certificates to conduct this A1 to A3 analysis of the big bang for buck components. We have entered a license agreement with CSIRO to access their NatHERS database, and we have run our algorithm 1 million times on every NatHERS certificate produced in the last 6 years. What that's got us is this package of data. Every grey dot here is a suburb, is a postcode. And behind all these grey dots sits 1 million data points. We can locate a single NatHERS certificate against the entire country. So this is national, but we can filter the state. With that data set, we're able to establish a benchmark, that is the average value, and we're plotting the carbon intensity per square metre of gross floor area. Once you've got a benchmark, you can set a target. And once you can identify where your particular project sits in this landscape, you really start to change the conversation. We are obviously very interested in doing better and empowering a literacy and decomplicating embodied carbon. So we have a web platform where you can input very simple rudimentary values and structural types and suppliers and start to play around to see that design decisions can start to move your dot around, as it were, and you can start to gamify it a little bit and start the conversation in a sector which really doesn't have much of a conversation going at the moment, and there's not a great deal of bandwidth to really get into the complexity of it. So I'll illustrate here what this aspect of it looks like. Here I've modelled a 2-storey brick veneer on a waffle pod. It's a normal sort of size building. It's sitting a little bit above the benchmark. I've set my own target, which is to be better than the state average by 20%. So my dot is above the benchmark. My target's down here, I'm 30% off. This tool allows me to start playing around with how I might move my dot down. It started at a 44-ton cold shell, and you can see most of that is floor and walls. First thing I do is change to a low carbon concrete. Get 4 ton out of the job straight away. That is a no-brainer. And here you can start to see that it is worth at least looking at that conversation and pushing pushback from contractors who might, have issue with it or examine further the costs attached to that. Second, more drastic shift is more a design shift here, where if you change to a lightweight structure, to a weatherboard structure instead of brick, you end up pulling a lot of carbon out of the project, and your dot is sitting well below target now. The bulk of what's left is the slab. It prompts a design inquiry then. Do we want a weatherboard house, or could we do a composite? So here I've got a fourth option, which is a brick ground floor structure and a weatherboard first floor. And I've also said, and the app allows you to look for a low carbon brick supplier and model that as well. So with this very simple exercise is starting to see how simple design decisions can move you around. You can see how you are compared to the rest of the state or the rest of the country. And to reiterate on those design decisions, we've taken from a 44-ton cold shell down to a 29-ton cold shell by 2 phone calls and deciding to use a bit of lightweight structure. And if we can do a 35% reduction 200,000 times, then we are talking like a big difference in the residential sector. To put this in context, and the reason why people might start engaging with it, I point to the mandatory ESG reporting, which is impending. Large corporates are being required to report on their Scope 3 emissions. That is big banks, big organisations. While they might not necessarily be attached to the residential sector, everyone in their value chain is starting to see that gathering data and understanding emissions is where the future is headed. And it's becoming good business to get your hands and head around embodied carbon. And if you're going to do anything at scale, it has to be because it's good business, not because it's a nice idea. So our platform provides this portfolio emissions snapshot where volume builders, developers and LGAs and portfolio institutions or financiers propping up the entire, supporting the entire industry can start to see their organisational benchmark. Where do they sit? If they've got targets, what is their starting point? And more importantly, if they've got a precinct, what is the total, the net impact of that precinct? And we can again use the NatHERS certificates that are attached to all the projects in that precinct, convert them all and output a snapshot of these, company or precinct emissions profile. And what that looks like is instead of having 1 dot on this scatter graph, we can see 1,000 dots, 1,000 homes, and see exactly where they are, allowing organisations to start to see what the hotspots are, how much of their projects are performing well, what is the split and breakup of their projects. And that, I think, getting your head around the scale of it has been, or is the focus of Carbon Trace. And the idea really being you have 2 aspects to embodied carbon in the residential sector. On the one hand, you have the bottom-up data gathering, that is project-specific information, project-specific designs, and decision-making that's being done at a mum and dad level, at a low literacy level. And at the other end of the spectrum, you've got portfolio scale reporting, where organisations have to understand their profile, set their targets, and report in a credible way on their Scope 3. And using a consistent method of measurement applied to both these spheres allows for a connection here, which starts to turn on the conversation. People can understand it at a project level, and it means something, and the impacts they mean, the impacts they might, or the decisions they might make at this bottom end of the equation translate to the top down, and you can see organisation trend lines starting to hit where they need to be. So I'll leave it at that. Essentially, we're thinking about starting small, reduce emissions 1 house at a time, but see the whole picture. Thanks very much.
Tom, thank you very much. Clearly, you've got your eyes wide open, recognising the relatively low carbon literacy at the residential project level, but many of the volume builders are going to be caught up in mandatory reporting, so that portfolio scale is also going to be important. There are a couple of questions in the Q&A about residential and others about cost. I'll be interested to come back to you in the panel discussion and ask, what are the cost bearings of that information, and can it lead to cost reductions We keep hearing about the cost of housing and the housing crisis. Anything that could add costs, I imagine, will meet significant barriers, but something with an opportunity to change materials to maybe a less expensive build could be a huge opportunity. Thanks very much, mate. We'll see you shortly. Now, finally, Dr. Dominic Hess, I'd like to bring you into the conversation to talk to about the curriculum for the Australian Institute of Architects, which I wrongly said at the introduction was available only to Institute members. Please correct me and take it away.
Hi, everyone. Can I just check that you can hear me because I can't see you?
Yes, can hear you and your slides are
Great.
nice and clear.
Great. So yes, it's a course that's free. It's online. It is through the AIA and funded by the Q. It's only if you want it to get the CPDs, then there is a cost associated. So my name is Dominique. I'm calling in from the lands of the Yalukit Willem. Currently, we're in Bulatu Dumbluk or warring season, depending on the language group. It's a time of mists and mushrooms. The course, as I said, was funded by DQ and was a collaboration between Caroline, Amanda and myself, as being all very passionate about a thriving, sustainable and resilient future, and embodied carbon being part of the knowledge we need to build up to be able to be on that journey. But we stood on the shoulders of some of the giants we've seen today, and many of the people that have been working in this area and providing the practical ways and tools forward. You can see them all here. I won't run through them, but thank you everybody for contributing. And there are small 5-minute snippets from all of these organisations within the course. What the course looks like is it's got a 5-step 1-pager. What are the key things you need to do? Then there's a toolkit that's free online. You can just flick through it. That's just got the basics, the information, the case studies and so forth. And then there is an 8-module curriculum, which steps out all of the aspects of understanding embodied carbon, understanding how to calculate it, understanding where the data comes from, then understanding how to use tools such as Carbon Trace and others, things to improve with case studies, then what does it mean specifically for architectural practice, and then into that innovation space. So where are materials going? So looking at bio-based materials, and also some activities and discussions around all of that. So the 5 steps are, I think I won't spend time running through them in detail, but you can imagine it's really that 1-pager that you can just hand out to everybody in a practice and say, this is what we're doing. Not everybody needs to know the details. The toolkit is just an online flip book that you can go through, and it covers all of this material. And I've mentioned that it's really about understanding the basics, understanding the case studies, understanding how to minimize it, and case studies and ways forward. The curriculum has us talking to a set of slides, a bunch of activities, case studies, a quiz, particularly if you're doing the CPD aspect for it, and then tools to use. And we go from as simple as what does a spreadsheet look like when you go to material safety data sheets to get the data out of it, or EPDs, environmental performance data sheets to get the data. What does that look like? And what does something like Carbon Trace look like? And what do more expansive tools such as the one that Paul spoke to look like? So you get to watch 8 modules worth of Caroline and I. We taught this live to a group of people here in Melbourne. And so we've tried to make the presentations as interesting and interactive as possible, rather than just a set of slides that have been flicked through. This is where the website, as I said, it's free to participate. You just need to sign in, set up a login, and then you can participate. It's only if you want to get CPDs, and if you're an AIA member, that there then is a cost. And I was also asked to give a couple of quick updates, which I'll do now, and then I might go into some of the detail if we need to, but I think we'd probably much rather just be in a panel and ask questions. You'll get these slides. So a couple of quick updates. because I also work on the Circular Economy Ministerial Advisory Committee, which has already been mentioned, and how does that integrate with what we're doing in embodied carbon. So the committee is looking for, has a group of 15 people such as myself in industry, in academia, in research, in government, talking together around what are the opportunities, the barriers, best practice, what do we need as far as enablers, how do we measure and communicate it, and making decisions based on evidence. So we provided a interim report just a month or so ago, and there's a lot more detail in it, and there are links at the end of the slides to get to all of this, but we've looked at focusing where it makes a difference, what are the enablers we need to develop. A quarter of our recommendations are around market creation and market transformation, because circular economy, which enables lower embodied energy carbon outcomes, is based on creating a market that enables that circular economy. So the materials need to be in the products that can then be collected to be recycled, to be reused. And we also need to look at that upfront. How do we reuse, adapt, fix, make last longer, and so forth. Stronger regulations are coming, looking at procurement and international alignment. It's also aligned with the net zero pathways, the net zero sectoral plans, and our reconstruction plans federally, as well as advice to the boardroom. And so that's going to feed into ESG reporting and so forth. A key output already from that, which you will mostly be aware of, and if you're doing work for the federal government, then you will need to have a circular economy plan. You will need to use their supply environmental sustainability plan process to demonstrate the validity of your process, and that includes embodied carbon, which is really the point of bringing it to this quick meeting. An example of an industry-led output is this Buildings 4.0 tool, which creates that enabling capacity for everybody within the industry to understand their role. So here we have quantity surveyors. What could their role possibly be within? Well, we know what it is in embodied carbon. They've been very supportive and developers of content there, but what is it for circular economy? And it does that for everybody within that. So just a quick update there. And lastly, working with Think, STEP, ANZ and ASPEC to do a comprehensive embodied carbon policy framework for the federal government. There's going to be an issues paper out very, very soon. And then the rest of the slides are really taking you through some of the content of the curriculum, much of what you've already seen in what other people have presented, talking around some benchmarks, talking around various tools, the importance of integrating it into practice. It's not just for the carbon accountants in the practice. What does it look like integrated throughout practice? Excuse me. And of course, the innovation aspect that I've spoken to. Also around how to think smartly, as we've seen with some of the case studies around how we put things together, and also the cautionary tales around some of this. You know, if you get aggregated materials, sometimes it's hard to recycle that. So as I said, there's links at the end. That's my presentation. I'm much more interested in the discussion, so let's move on.
Fantastic, Dominique. Thank you, and thanks for keeping an eye on the time as well. Let's tease out what's been said. If I could ask the other panelists to turn their cameras on and to rejoin, that'd be fantastic. Dominique, while you have the mic on, I wanted to ask. I think there was a slide there showing a showing the curve. I was just wondering, is that the curve of opportunity that shows just how much can be achieved early in the design phase? Could you tease that out a little bit, because that's one of the things, the power of design to design out, rather than wait till later in a project and then have to retrofit when it's too late.
It's not just the power of design, right? It's the power of the specifier. It's the power of the portfolio manager. And it's if we do things, if we think about reusing existing buildings, if we think about adaptive design, if we think right up front and bring our creative skills to bear, then we can save all of the impact that will happen if we build too big, if we build something new, if we build of materials that are high of embodied carbon. So those initial decisions, and those initial decisions are also your greatest opportunity to save money. So it's not just about saving embodied carbon, it's also saving money. You know, there are countless examples out there where the reuse of a building has saved the building in Sydney, done by Built and others, you know, saved $150 million because they reused a structure rather than pulling the building down, partly because they just didn't need to disrupt the city as much and the costs associated and the time associated with all of that. So, yeah, that's really that idea of that graph.
Makes a lot of sense. Tom, can I come to you at a residential scale?
Yep.
Are there also cost savings to be had by bringing this decision making right up front?
Yeah, look, I think there are. I think embodied carbon is a more expensive build is not necessarily connected to its embodied carbon. You can have a cheaper build that is also lower carbon. I mean, we think about lightweight systems, weatherboard, fiberclad, Hebel, compared to more carbon-intensive modes of construction, masonry, double brick concrete. I think really understanding the impacts in a measurable way is a way to connect those decisions. But yeah, I think it's about awareness first, and it's not a straightforward, it will cost more because it's lower carbon. That simply doesn't carry through in the residential sector, to my experience.
Terrific. While I've got you, one question on data. You mentioned that you're taking the data care of the CSIRO from NATA's reports. One of the questions in the Q&A was, how does that relate to LCA information or EPD information for particular inputs?
Yeah. Firstly, we keenly await neighbours releasing their default emissions factors, which we will adopt straight away. At the moment, we're using EPD Australasia, and certainly we can onboard any supplier's EPD. The whole point in it is you can compare suppliers. That's starting to drive decarbonisation up the supply chain, which is exactly what we want. In terms of the comparison to a full LCA, which will analyse internal, externals, the whole kit and caboodle, it does depend a little bit on the typology, but we've found ourselves to be within 60 and 80% of the total, just in capturing that cold shell. And again, that rings true to the results from Paul and both Pauls, in that the superstructure, the concrete, that external component are the big offenders. And so if you get those right, and if that's a relatively low intervention, low friction way to understand those bits of the equation, then certainly expand later on, pick up the last 20%, whatever. But at the moment, that is available right now and is a big win. So that's where the focus is. But yeah, it's not a full analysis. We're not saying that it is. We're quite clear on what it is and it isn't. But it's getting most of the way there.
And you'll continue to evolve the tool as more data becomes
That's
available.
right. As you improve data feed and data quality, you can collect more information. It all comes down to data, but more importantly, scalable and consistent data. It's got to be something that is applicable at a national level. There's no point one person doing it fully and then they got a number, but it doesn't mean anything because it's not in context to anything else.
Terrific. Thanks, Tom. Now, Dominic, you talked about markets and the market for circular economy. I'd like to take the concept of markets and ask the two Pauls, the market for a different kind of building, the total systems benefit that Paul Stoller, you talked about. Is there a market for this? Are clients asking, or if they're not asking, are they receptive when you give them these new ideas?
You want to go first, Paul, or do you want me to?
I'll go first, then leave you with the final word. Yes, in principle, some of the clients of the big building world are very receptive to this, especially companies that have made substantial ESG commitments, broader sustainability commitments. They care about being effectively climate active. So they care about real outcomes. And we've got great systems in Australia to measure performance and track and assure performance. So the systems we have for kind of monitoring our progress and for linking that back to kind of business commitments actually is driving a lot of the change. It's still not, it's probably a relatively small portion of the overall building market, because the overall building market has a lot of not big professional builders and developers and asset owners who just don't have the resources to tackle all this, which is why tools like Tom's are so important. They can automate things for the projects that are too small to have everything done specifically for them. But yeah, the market will grow for total system benefit as the awareness of the impact and the benefit of it grows.
Yeah, I think that's a really fair point. That once people understand it, they'll be into it. I think an awful lot of the big end of town is already there, and certainly from our point of view, generally speaking, the trajectory is moving in one direction and one direction only. So anybody who's got an eye to the future of a building, and if they're an asset owner or they're somebody who wants to develop and be able to sell, their focus is on the future performance, and you want to be able to sell a building for the highest amount of money, I suppose, simple terms. So if you can sell a building that's ready for 2030 or ready for 2040, you can command a premium for it. And so I think the penny has dropped for an awful lot of our clients, and for those that it hasn't, or it hasn't dropped as deeply, it's a pretty simple conversation, and something that, I think everybody in this room obviously is doing this anyway, but it's something that we're advocating for all the time. And generally speaking, we haven't had an awful lot of no. We're getting a lot more yes than we're getting no. So the trajectory is only going one way.
That's encouraging. Nice to hear. Thanks, both Pauls. Philomena, I'm interested in your guide to disassembly is relatively new, but what's the interest in the market been? Have you got any? Who's asking for it? Who's using it? What's that conversation look like?
Well, as I mentioned during my presentation, it all really started because a client asked us about it. So I want to think that that's going to be the beginning of something. And then it's going to be up to developers, builders, and architects to propose that on projects as well. And also, like we said right now, like we just said that, the things are going in one direction only. So even if I've not seen a design for disassembly implemented in as many projects as I would have liked here in Australia, there are too many policies out there that are really sending a strong signal to the market. So I'm confident that design for disassembly is going to become, I don't want to say business as usual, but a lot more commonplace within the next few years.
Fantastic. Paul Reedy, you mentioned challenge in getting some materials in the Western Australian example you gave. What M in MECLA is materials, and we have working groups on particular groups of materials. What can you tell us that the working groups can tackle?
Yeah, good point. I think one of the key things was the steel options that we were looking at, getting recycled steel certified to be used again in a structural case was possible, maybe, but involved something like 5 tests, and I'm not completely across it, but involved something like 5 tests, and we would have to be shipping steelwork across the country in order to conduct those tests. Probably, well, that is to do with the fact that the people that do the tests are steel manufacturing businesses. Recycled steel is not their business, and not necessarily something that they're directly interested in. So I can kind of half understand it, but if we want to use recycled steel, we've got to be able to make testing of it efficient, such that it can be reused rapidly and everywhere, rather than having to take. There's no point in saving embodied carbon if the cost is embodied carbon to ship something from one side of the country to another to test it. And Perth is a pretty unique case in terms of its isolation globally. And then in terms of geopolymer concrete, I think the issue was largely one to do with IP. I think I answered it in the chat. Largely an IP related issue as to who's got it. There's an awful lot of low cement or cement replacement products on the market that take you part of the way there, And we're working with BGC in Perth. They were really keen to experiment further with that, and we're looking at a much higher cement replacement and trying to work through the problems of that, right? It's not necessarily, doesn't work exactly the same as normal concrete, and lots of people will poo-poo it because it doesn't. But it can be, those questions can be resolved. They might have program implications. On that project, it's a small scale building, so the program implications aren't replicated 40 times as you go vertically. But there's lots of places where you can use lower embodied carbon concrete or lower cement concrete. So I think understanding and demystifying some of the problems with that, or some of the issues with that. You know, concrete might take slightly longer to cure. Concrete might cure slightly differently. You might have to grind off the surface of the concrete if you've not got as much cement in it. There's different implications. It's not a straight swap always, but there's always possibilities.
Okay, good to know. Thank you. Now, Dominic, you've made a couple of comments in the Q&A and the chat about EPDs and supporting innovative materials. Can I ask you to talk to that point, please?
Yeah, and I thought others might want to contribute to that, their thoughts as well. We have been talking federally about EPDs and also how to support both innovation and SMEs, because often the process of gathering all of this information and so forth is something the big guys can do, but the little guys are just doing what they do every day and just, you know, getting through, not necessarily looking to meet all of these criteria. And so how do we not disadvantage the small, agile people that we exactly want to support in our manufacturing locally? And so, yeah, discussing what that could look like. I'm in no position to say what will happen and what won't, but, you know, recommendations are to support SMEs, to support them with EPDs, to support them with the capacity to be part of the journey.
Certainly from, sorry, go ahead.
Philomena, I was just going to ask if you have a perspective on that, and then Paul Reedy, back to you.
That's $1 million question, Dominic. I was actually thinking about it. I was looking at some templates yesterday of how people can self-report on their own materials, so they can fill out the template and provide as much information as they can so that they can compile their own EPDs. The problem probably is the third-party certification. I just don't know how to get around that. And, you know, if we want to keep invested in low embodied carbon solutions and making sure that we're using the right kind of information on projects, we do need to make sure that it's also a transparent process. So how do we do that now, having someone doing the check and balances?
So one of the things we're thinking about, and this is where the whole competition is a difficult one, and we're also looking at that as a barrier. So how do we bring together sectors and do EPDs in sectors that people can then draw from? But these are things we're discussing. You know, we can make our recommendations, and you'll see at the end of the year what our final recommendations are. But we're very much grappling with this capacity building to respond by SMEs.
Yeah, I'm looking forward to read the recommendations. Because it's a little bit like we're talking about before. At the end of the day, it's all well and good that the big builders, the big material suppliers are doing the right kind of work. They have the scale and the resources to do that. But there is like very, what about like the small material suppliers, the small builders, the small residential projects? You know, everything, we need everything at this point to move the needle. So yeah, important to bring everyone on board.
In terms of material innovation, we found in the Perth project, an awful lot of the suppliers we were talking to were really small. And we're doing the ones that were doing the most interesting stuff, like recycling, you know, having tiles or bench tops made out of recycled glass and recycled textiles and all these kind of things. In principle, it's an awesome proposition. Getting a business that's, you know, starting up to have a $50,000 input of an EPD or whatever it might cost is a really big impost. Finding ways to elevate that would be awesome. I think, Dom, it's a you know, the brick supplier that we were talking to, they're a small, again, relatively startup proposition, but doing things completely differently to, you know, avoiding firing the bricks and all kinds of other things. They're using cement in order to do that, but They've got a lot of recycled content in their products. They're really going after the innovation piece, and getting them to have an EPD is really hard for them to be able to afford in the first instance, but also for them to factor into the process of them producing new product and new innovative product. So finding almost a shortcut to that to be able to prove up, and we found on the project in Perth that we were balancing raw embodied carbon numbers against all of the other pieces of innovation that they were doing, and we assessed. The project was very seriously looking at, do we use recycled brick versus using a new brick, and we chose to go with the new brick purely on the basis of it's an innovative proposition that the project should be sponsoring, rather than using a recycled product, which everybody knows about and is already there and would be a lower carbon proposition, but isn't exactly innovative.
And also, if I could jump in, the other crucial component there is to find the right incentives. I mean, I do understand, obviously, that for big material suppliers, they go through the homework, through the expense to putting all that time and resources into this, because they are going through big projects and important ratings, and basically they're going to be rewarded for it. But what about the smaller ones? Like, what are the incentives for them? Why would they go through the trouble of having to put an EPD together? So it's also about trying to find the leverage that is going to push them into that direction.
And perhaps that's where, if the market understands that there is a significant difference in using one material over another, by easily being able to model what happens if you change emission factors, and you make that process something that you don't need to be a carbon nerd and get the Excel thing going and dig into all the, but you just like, oh, okay, I got 6 choices here. Who am I going to choose? Like, it's the chicken and egg in a way. If you make the market understand it to that level, then they will ask for the EPD data. And I think that's got to be a big part. Bringing along everyone on this ride, not just the specialists, is key, I think.
Yep.
Very quickly, because we are fast coming to the 12:30 mark. The guide for disassembly, Philomena.
Yes.
There have been several questions around fit out and the fact that the churn of fit out cumulatively is very big relative to the life of the building. Is there a component in your guide for fit out disassembly as well?
The guide is definitely applicable to big building as much as fit out, so you can use that for fit out projects as well. But my invite would be, if we're thinking about fit out, especially because we know that usually they have an average lifespan of 5-7 years, we should be thinking about it even differently. So one thing that we're looking at Build quite a lot is finishes the service, services the service, and all that kind of stuff. Like, like making sure that you're leasing the materials rather than using them, and then having to take them apart and use them elsewhere. So if any of you would like to have a more detailed conversation of that, I'd love to have a chat.
Okay, terrific. I noted when I visited the Green Building Council's office in Barangaroo recently, their fit out is fit out as a service. They don't own it. They didn't, so they essentially have that as a service, which is great from a circularity point of view. Look, we're fast out of time. If I could ask each of you, I'm a newbie to decarbonisation. If I could ask you one thing, what can I do to reduce embodied carbon from your role in a project? If we could start, let's go in order of speakers. Paul Stoller.
I would say do more with less. Figure out how to build the least building, adapt the existing buildings, that just use the fewest materials. That's the fastest and typically most cost-effective way there.
Okay, nice and simple. Thank you. Paul Reedy.
Use an existing building.
Okay.
Don't build a new one if you can avoid it.
Philomena?
Think about not only the first life of materials, but also the second and third life. So think beyond project completion.
Okay, that's powerful. Tom?
Start somewhere and don't try and boil the ocean.
All right, very good. And Dominique Hess?
Create the capacity within your organisations to understand what's happening and why. Don't just tell people what to do, but actually that understanding to have agency in the solution.
Fantastic. So much collaboration here, and that's a great note to finish on. yes, MECLA is all about collaboration. I really am so grateful to the 5 of you for coming to speak with us all today. This is one of our most popular events yet. So a big thank you to Paul Stoller, Philomena Bashara, Paul Reedy, Tom Petty, and Dominique Hess. Thank you also to people, attendees for online contribution, the chat, the questions buzzing away. We'll be taking a copy of all of that and uploading that with slides with permission, and also a recording of the event. Adding to our resources page, please everybody note our resources page is forever growing, a wonderful set of resources to help on our journey to decarbonisation. As always, I'd like to thank Monica Richter from WWF for her determination, insight, and experience that makes MECLA succeed. A big thank you to Kati Vahayan and Alexi Barnstone from Climate Kick. Behind the scenes, they've really made this event work and succeed. They run our secretariat and, well, worth their weight in gold. And as ever, I remind everybody, keep an eye on LinkedIn for our MECLA updates and relevant industry happenings. And MECLA doesn't work without you. It is a collaboration across the industry, all working in that pre-competition environment to drive change. So for dialing in, for contributing, for being on the panel, thank you, everybody. And I look forward to seeing you again soon.
And
Thanks.
thank you for great
Hudson.
hosting.
Thank you, everyone.
Thank you, Hudson.
Thanks.